20-1s. Welcome to the second half of the trig units. All that work with the Cartesian grid is now done. So we kind of shift gears here, and now we're going to work with the sine law and cosine law. It gets away from the Cartesian grid, reference angles and things. So just very quickly, in the past, you've calculated angles and sides in right-angled triangles. You've used Pythagoras, a squared plus b squared equals c squared. You've used what I refer to as the 180 rule. The three angles in any triangle have to total 180. And you've used the trig ratios, which we did use a little bit last unit, or the first half of this unit, sorry, the SOHCAHTOA. Well, the key here is this information works with a right-angled triangle. But if we have a triangle that's not a right angle, which are triangles all over the place in our world, those aren't going to work. So that's what this part of the chapter is going to do, is work with non-right angled triangles. Now, real quick introduction, the sine law, that's what it's summed up into. Calculations aren't real difficult, pretty straightforward. Only thing is, if you have any non-right triangle, couple things to review. Angles are always labeled with capital letters. Angle ABC, or triangle ABC, is made up of angles A, angle B, angle C. Please remember that the sides of a triangle, one way to label this bottom side would be side AC, but it's also more commonly referred to as side lowercase b. Angle B, which is labeled capital, is always across from side lowercase b. Side AB, well, another way to call side AB is because it's across from angle C, it could be side lowercase c. And obviously process of elimination, but side BC here, because it's across from angle A, could be referred to as side A. So that's where the variables come from in the sine law, where side A over the sine of angle A should give us the exact same value as side B over sine of angle B, and side C over sine of C should give the exact same value as well. This is going to basically come down being able to plug stuff into the ratios and cross multiplying. Please note, sometimes some resources will flip the entire basically ratio setup. It'll work the same way as long as you're consistent. As long as all your sides are top or bottom, all the sine of angles are all top or all bottom, either works. And we don't have to work with all three in a question. Usually a question will be able to fill in enough information in two of the ratios, we can put them together. So we would work with sine A over A equal to sine B over B. Or we might work with sine A over A equals sine C over C. Or we could work with sine B over B will equal sine C over C. You don't have to work with all three at once. Substitute in what you know, choose two of them, and work with them. The last little bit just before we get started, as always, to find an angle, we always want to second function or inverse the decimal value to get the angle. And we've done a little bit of that previous in this chapter as well. So let's jump in and see what we can do. We want to solve for this example 1, that particular triangle. Solve the triangle means solve for all the unknown parts. Well, the one thing that's important that you understand for the sine law to work is you must have an angle side pairing. If you don't have an angle side pairing, sine law won't work. And what an angle side pairing means is that you have side A and angle A, or you have side B and angle B, or you have side C and angle C. You must have both the angle and the side of one of the pairings in order for this to work. So I'm going to label things just so I have an identity for them. Across from angle A would be side A, across from angle C would be side C, across from angle B would be side B. All right, so with this, let's plug in what we know. So I'll start just in alphabetic order. I'm going to go side A, 16, over the sine of angle A, 55 degrees. Now I'll go to my B's. Angle B, which we don't know, so sine of B, and side B, I also don't know, so I'll leave it at that. And then we have sine of C, which we don't know, over, that's under side C, which is 12. So to start with, you can see that one of the ratios is complete because we do have angle A and side A. There's the angle side pairing I was talking about. As soon as we know we have a side angle pairing, that way we can now work with it. So this ratio is important. 16 over sine 55. B over sine B, we don't know anything there. That's not doing anything for us. So right now, I'm going to get rid of that. And I then have 12 over sine C. In this case, I have one unknown. This allows me, with my angle side pairing, my second ratio, I can now cross multiply. Please be careful with your cross multiplying, that you're not multiplying by 55, but you're multiplying by sine 55. Cross multiply, multiply what you can, divide by the extra piece. Just going to get rid of my scribbling here so I have more room to work. And when I do 12 times sine 55 divided by the 16, that's going to equal what I have left over, which is sine C. So on my calculator, 12 times sine 55 divided by 16. 12 times sine 55, enter, and I'm going to divide it by 16. 3, 4 decimal places is always best. Decimal 6144. So this is 0.6144. That still equals sine of C. I need angle C. I have not calculated angle C. This decimal is sine of C. Remember, to get the angle, you need to second or inverse to get the angle. So we need the inverse sine of decimal 6144. That will give me angle C. And when I do the inverse sine of decimal 6144, round to the nearest whole degree is acceptable unless it states otherwise. We're looking at a 38-degree angle. So I can now put angle C in here as 38 degrees. So this question said to solve the triangle. We now have two sides known, two angles. I still need B and B. Well, easiest one to start with would be angle B, because angle B, that's just the 180 rule. 180 degrees total. Take away the two angles that you know, and that leaves us with angle B at a size of 87 degrees. So there we now have 87 degrees. Now, I always love this because when I ask this question in class, what can we do to find B? Now that we have two sides, someone shouts out, Pythagoras! And I throw something at them. No, we can't use Pythagoras because it's not a right angle triangle. So now, what do we have to do? We have to go back to the sine law. We had sine 55 over 16. That was our angle A, side A. Well, now we're trying to find side B, and we know angle B, so now we can say that this is sine 87 over side B. And we're going to cross multiply again. Cross multiplying, multiply what you can. 16 times sine 87 divided by the extra piece, which is sine 55. When we do that, well, this is nice because it will equal B exactly. So 16 times sine 87 divided by sine 55. Let's see what that works out to be. 16 times sine 87. And then we divide by sine 55. I always, myself, don't like to punch everything in at once. I like to break it into steps to make sure I don't punch too much in incorrectly or that the calculator does do order of ops the way I want it to. So lengths to the nearest tenth. Side B works out to be 19.5. So side B is 19.5. And there's the solving. Using the sine law twice, plugging in and cross multiplying. Not too complicated. Example 2. Give it a try. Find AC. I like to label. So we want AC, which is also side B for simplicity. Here we have BC is 20, got it, which is also side A. Angle A is 31, got it. And angle C is 104. So this question wants to know what AC is. So, or I'm just going to start calling it side B because that's what we use in the sine law. The problem here is that if I set up what I know, 20 side A over sine of A, which is 31. 20 over sine 31 will equal angle C, so sine 104, over side C, which we don't know, which also could equal sine of B over side B, neither of which we want. And the problem is, that's the unknown that we want. So I could figure out what C is by the sine law, but that still isn't going to help me figure out what B is. Problem here is some students, we don't have enough information. Every time you're looking at a triangle question, think of the 180 rule. As soon as two angles get given in a question, we know the third angle. All three angles have to total 180. So if we have a 104, a 31, B has to be a 45-degree angle. So I do know that that's 45 degrees. Consider the 180 rule all the time. So now I have angle side pairing perfect. I can start with that. 20 over sine 31 will equal, we want to know what B is, given that angle B is 45. Even though it wasn't told to us directly, we can figure that out. Cross multiply. 20 times sine 45 divided by the extra piece, which is a sine 31, and that will equal the b value, which is what the question asks for. 20 times sine 45 divided by sine 31, the length is 27.5. There you go. Fairly straightforward process, cross multiplying. Example 3, find angle y to the nearest degree. So here we go. A sine A, B sine B, C sine C. Does the labeling really change things up? I don't think so. Across from angle X is side X. Across from angle Z is side Z. Across from angle Y is side Y. What are we trying to find? We're trying to find angle Y. Do we have an angle side pairing? We do. X and side X. There's a great start. So as long as I have that angle side pairing, 20.3 over sine 105. What am I trying to find? I'm trying to find angle Y. What's nice is I do have side Y. So we have 15.1 over sine of Y. In this case, I don't know angle Z. I don't know side Z, but I don't care because I have enough information to solve the question. Cross multiply. 15.1 times sine 105 divided by that extra piece, 20.3. What is that going to equal? It's going to equal sine Y. We won't get the final answer because we need to inverse sine to get an angle. When I do this part of the calculation, again, 4 decimal places is acceptable to get an accurate answer. But what do I have to do? Because that equals sine of Y, we need to inverse sine, decimal 7185, to equal angle Y, which in this case, 46 degrees. And that's all there is initially to the sine law. Pretty straightforward to remember, even though it is on a formula sheet for you. But once you have that information, it's just a matter of cross multiplying. Like these examples had, a couple things you have to consider, but fairly straightforward. Now there's your assignment, but be careful, don't stop the video because the video's not over. This textbook and questions right out of your work booklet, not a worksheet, but out of the booklet, those are good questions for the sine law. We have one more thing to talk about with the sine law. So go do some work, make sure you understand the sine law, and come back and finish the video, or keep plugging away with the video and do both assignments at once. Whatever makes you happy, but here we go with the next parts. Now the sine law, what we have is what's called the ambiguous case. Now the ambiguous case, please understand, part of this isn't in the booklet. This is just a little bit of a side note. So have a piece of paper, jot this information down. Triangle ABC, angle A is 30, side B is 20, side A is 12. We want to solve for angle B. Will the sine law work here? It will. Why? Because we have the angle side ratio. So we can set it up. 12 over sine 30 equals, trying to find angle B, so sine of B over side B, which is 20. If we do that calculation, always please double check that you're in degree mode. So we're just going to go sine of 30 times the 20 divided by 12. And then we need to inverse sine that to get the angle. We get angle B equal to 56 degrees. Sine 30 times 20 divided by 12 gives us sine B. Remember to inverse sine the value, and angle B is 56 degrees. So we just talked about it, not a big problem. Or is it? There's our 56. What's important here is that 56 degrees is not the only solution. This is a case where it's a unique situation. We'll talk about why it is after we look at this particular example. Here's why. If I want to calculate the height of H here, the height of the triangle, well, I can go back to trig from last year. A right angle triangle, real quick review. Remember, if we want to find this, I'm going to use 30 degrees. This is the opposite using hypotenuse. So we would do sine 30, opposite H over hypotenuse 20, cross multiply. We reviewed this in the past. So H will equal sine 30 times 20, and H works out to be 10. So I hope that makes sense. But here's why it's important. Jumped ahead on me here. We have, oh no, I lost one of my screens. Bear with me. What you have to understand, let me just, sorry, but so that's what we have. There's our triangle and there's our height of 10. This question says that we have angle A equal to 30. We have side length B is 20 and side length A is 12. But what you have to understand, I can actually create, if I take this 12 and instead of putting it over there, I can drag this 12, because it's longer than our 10, over to here. And I still have all the right stuff for this triangle. I have my 30-degree angle. I have my side B equal to 20. And I still have my side A equal to 12. So we actually have, in this case, not one triangle that we started with. We have now the initial triangle that met the parameters, but we also have this second triangle which also met the parameters. So B's been moved over here. Is that still 56 degrees? Well, I'll tell you now it's not. So this is what's called an ambiguous case. There's more than one interpretation. We have angle A, 30 degrees. AC, a length of 20. Side A, 12, but drawn two different ways. It's an ambiguous case. And what happens is that our second angle B down here could be actually 124 degrees. I'll explain to you why that's possible. If we take a look, and I take this 12, and I now draw it over here instead. So I've transferred that over to that position to get the second possible triangle. Well, what I've now created actually, because these lengths are the same, I have an isosceles triangle. Two sides that are the same means two angles are also the same. So the trick is to remember that if you solve it the first way and get 56, what's this second new angle going to be? Well, if that's a 180 straight line, all we have to do is take 180 degrees, subtract the 56, and get 124. So we still use this 56 for the first triangle, and then we use it to help us find the angle in this second possible triangle, an ambiguous case situation. Here's what's important. There are three key pieces of information you need to know if something is the ambiguous case. The first one is the triangle information is given as angle side side, because ambiguous case triangles can be a pain in the angle side side. If I go back to the original one we just looked at, go to the original question, what information, so I'm just going to go back a bit here, what information was given? We were given an angle, and as I move around, the side and another side. That's how the information was given. Okay, if I'm given, say the 30 degrees was in here, well then it would have been side, angle, side. But it wasn't given there. If I can look at the information and it's angle, side, side, as I work around, well, that's one step towards ambiguous case, because the ambiguous case is a pain in the angle side side. The second key part is the given angle acute? Do you have an acute angle? Is it an angle side side? Is it an acute angle? If those two are yes, we go to the third. The third piece is the small side across from the angle that's given. Is that the case? If that's the situation, all three of those are yes, yes, yes. Angle side side, acute angle given, and the smallest side is across from the acute angle, then yes, you have an ambiguous case, and there will be two solutions. You can use the sine law to calculate the first, and then 180 minus your first one will give that angle in the second situation. So let's go back to the notes and see what we have here. Page 13 looks at the ambiguous case. If you're given triangle ABC, and just for simplicity's sake, let's get rid of this decimal. That's not necessary. So ABC, I'm going to sketch it. A I'm going to put down here because it's an acute angle, so we have a 29-degree angle. Side B is 20.5. If I just finish my labeling ABC, side B will be down here at 20.5. And side A is given as 12.8. This question says sketch the two possible angles, which is telling us we have to have ambiguous here. So do we have angle side side? We're given the angle, and then, oh, there's the side beside it, and as I keep going around, there's the next side. So I definitely have angle side side. Second situation, is it an acute angle given? Absolutely, 29 degrees. And the third situation, small across from the angle. Is the smallest given side across from the angle? 12.8 is smaller than 20.5. So yes, it is. So there is the first possible triangle for this situation. A is 29, side B is 20.5, and side A is 12.8. Now the trick is it says sketch the next triangle. Now this honestly can be tricky. Now here's how I always approach it. Angle A29 can't change. I need these three pieces of information to still be there. So what's nice is I still have 29 degrees for A. Now, what does that mean? I need to take one of these sides and move one of the sides into a new position. Which side do I have to move? Well, if 29 has to stay the same, I have to leave those the same. That's nice. Because to get this, I still need AB and AC to be what they are. But this other side is now going to move somehow. But I have to move it so I don't change lengths. Which means I can't move it this way, because if I move it that way, this side becomes shorter. I have to move my 12.8 down in this direction so that I have those two triangles. And that's what I will end up with. I'm going to end up with those two triangles where I have ABC, and then I have A, but C, B becomes an obtuse. I still have 29 and 29. I still have 20.5 and 20.5. And I still have 12.8 and 12.8. But I took this side and I rotated it down to that position. So there would be my next triangle. I did that one different than the booklet. You could see in the booklet how it had B and C switched. There's more than one way to approach this. There's not just one right way. So if we take a look again with what the booklet had. Booklet had the triangle, had A as 29. There's our 20.5. But this time, the booklet had our C value and our B angle. So again, I need to keep this information, and this information. This angle has to stay the same, so it's this side that needs to be rotated. And I can't rotate this down that way because that'll change that. So this side would have to switch over. So I would have the new triangle, 20.5. I'd still have 29 degrees. But now my 12.8 comes down like that instead of out like that. Different ways to draw a triangle with those three key pieces of information. So now we solve it. What does that mean to solve it? Well, let's find angle B. We have our angle side. So 29 sine of 29 over 12.8 will equal sine of B over side B, which is our 20.5. Cross multiply, and we'll get sine of B to be equal to 0.7765. So inverse sine angle B is 51 degrees. So there's the solution for angle B, which is 51 degrees, which now remember in this second triangle, it said that 51 was down here, but that also means 51 is there. So this angle would be 180 minus 51, which would be 129 degrees. And there's the two different angles that result because of ambiguous case. You could then find side C and angle C, but this is the key, is finding the unknown piece. So, ambiguous case, a little bit different. Very quickly, let's take a look at example 3. So, last one here. KLM. I will give you a hint that a lot of times I like to, and I'm just going to go 37 degrees again. I'm going to cheat a little bit. There's M. So I'm going to put side M is 85. And I just find myself, if I do always, I try to go angle, side, side. Because this way it's, follow a pattern, it can be a little easier. So we have angle, side, side. 37, 90 kilometers, 85 kilometers, angle, side, side. Do we have an acute angle? We do. Is the short side across from the angle? It is. So we definitely have ambiguous case. What does that mean? 37 stays the same. I can't move these two sides, so I have to move this 85, but I can't move it down. I have to swing it over this way, otherwise I'll change the 90. So my 85, instead of being out here, would swing down like that. So that's roughly what it would be. And there's my 85. Still have the 90, still have the 37, but instead of having the 85 out to the right, it's now swinging in to the left a little bit. So I can calculate angle L now here using the sine law. There's my sine 37 over 85 will equal sine of L over 90. From there, cross multiply, and angle L will work out to be, in this case, 40 degrees. But that's 40 degrees for our first triangle. In the second triangle, if it was 40 down here, it would also be 40 there, which means this angle in here would be 180 minus 40, or 140 degrees. So angle L in that triangle would be 40 degrees. Angle L in the second possibility would be 140 degrees. There's ambiguous case. You won't be asked a ton on ambiguous case, but you need to understand it. There's a couple of questions to add to the sine lesson that incorporates ambiguous case and gets you thinking about that. Sine law, pretty straightforward. Ambiguous case makes you think a bit, but manageable. Practice it. Have fun.